Hey everyone, welcome. Today we're going to jump into a fascinating paper that tackles a huge problem in AI, how to make them think harder without, breaking the bank. It's a new method called DeepConf, and the core idea is to teach an AI a very human-like skill, how to trust its own gut. So, let's get into it.
So, first things first, when you give an AI a really complex problem, one that needs serious reasoning, how do you get it to actually think hard about it? I mean, it can't just lean back in its chair and ponder, right?
Well, one of the most popular methods today is honestly a kind of controlled chaos. You basically tell the AI to generate a massive brainstorm of different ways to solve the problem. It's a bit like throwing 100 darts at a board at once and just hoping one of them hits the bullseye. Now, this brute force approach actually has a name. It's called self-consistency. And the big idea behind it is pretty intuitive. If you make an AI come up with, say, 500 different ways to solve a problem, the answer that pops up most often is probably the right one. It's basically a democracy for AI-generated ideas. Here's how it works in 3 simple steps. First, the model just goes wild, generating hundreds of different reasoning paths. Then, for each of those paths, you just pull out the final answer. And finally, you just count them up. Whichever answer gets the most votes wins. It's simple and it often works pretty well, but there is a massive catch. And yeah, that catch, it's the cost. This method might be powerful, but it is an unbelievably expensive guessing game. The amount of pure computational power you need to generate all of those potential solutions is, well, it's staggering. Just to put that into perspective, the paper points out that for a single model to answer just one set of tough math questions, it can burn through 100 million tokens. 100 million! Those are the little bits of data the AI processes. That is a huge amount of energy and a huge amount of money for just one task. And this gets us to the real fundamental flaw in this whole voting system. A standard majority vote is democratic, sure, but it's not a meritocracy. A completely clumsy, error-filled line of reasoning gets the exact same vote as a brilliant, perfect one. And if you just happen to generate enough of those bad ideas, they can actually gang up and outvote the correct answer. So this is where the DeepConf paper comes in with its really elegant solution. The researchers basically asked, what if the model could just listen to itself? What if it could somehow measure its own confidence at every single step and use that as a signal for how good its reasoning is? And it turns out that signal actually exists. See, every single time a model generates the next word, it calculates the probability for every possible option. If the model is super certain about the next word, like it's practically screaming, I know the next word is this one, that's a sign of high confidence. But if it's kind of shrugging its shoulders with lots of words having a similar probability, that signals low confidence. Now, people have tried using this confidence signal before, but there was a big problem. They would usually just average the confidence score across the entire chain of thought. That's kind of like getting a final grade on an essay, but not seeing any of the little grammar mistakes you made along the way. A few really confident steps could totally hide a critical, fatal error buried somewhere in the middle. DeepConf takes a totally different route. Instead of looking at the overall average, it zooms in to find the weakest link. The insight here is that the moments of the lowest confidence are often the exact points where the model starts to go off the rails. It's like a quality inspector looking for the one faulty part on an assembly line, not just the average quality of the final product. Okay, so how does DeepConf actually use this weakest link signal? Well, it's applied in 2 incredibly clever modes. One that works after all the ideas are generated, and another that works in real time as they're being created. The offline mode is pretty much a smarter, weighted voting system. Once all the reasoning paths are finished, it just gives more voting power to the ones that were consistently confident the whole way through. Simple. The online mode, though, is all about efficiency. As a model is generating a thought, if its confidence suddenly drops below a certain point, DeepConf just says, nope, this path is going nowhere, and terminates it early. No more wasted energy on a bad idea. So the big question, does this actually work? Well, the authors laid out the evidence from their experiments, and the results they reported are, well, they're pretty darn significant. We're talking big improvements in both accuracy and efficiency. So according to the paper, on a really challenging math competition benchmark, the standard method got a 97% accuracy, which is already really good, right? But by applying DeepConf's offline filter, just reweighing the votes based on confidence, the authors report that accuracy shot up to 99.9%. It nearly eliminated all the errors. And here's the real kicker. These accuracy gains happened while being dramatically cheaper.
That online early stopping mode was able to slash the total number of tokens generated by up to 84.7%. So the claim here is that it's not just more accurate, it's getting there using a tiny fraction of the computational resources.
This table really drives the point home. With a different model on another benchmark, standard voting gets about 87% accuracy, but it uses over 350 million tokens to do it. The online DeepConf method, it boosts accuracy up to over 92%, while using less than a quarter of the tokens. It's the best of both worlds. Higher accuracy, massive savings. But okay, it can't be perfect, right? Nothing ever is. For any new method, we have to talk about the limitations. And, to their credit, the authors are very transparent about a key weakness, something they call the confidently wrong problem. The problem is exactly what it sounds like. Sometimes a model can follow a completely flawed path of logic, but be absolutely certain at every single step that it's on the right track. In those cases, DeepConf can actually backfire. It might prioritize the wrong answer precisely because the model's gut feeling is totally misleading. Confidence is a great signal, but it is not the same thing as truth. But, this isn't really a failure of the method, so much as it points to the next huge challenge in AI research. The question it leaves us with is one of calibration. How do we teach these models not just to be confident, but to be confident for the right reasons? How do we improve their self-awareness, their ability to know what they don't know? All right, so let's boil this whole paper down. The argument is that brute force AI reasoning is powerful, but it's just way too expensive to be sustainable. DeepConf offers a solution by using the model's own internal confidence as a quick and dirty way to judge the quality of its own ideas. It can do this after the fact with smart voting or in real time by cutting off bad ideas early. The result? Better answers for a fraction of the cost. And that leaves us with a pretty profound question. This paper suggests we can teach an AI to trust its gut. But the real challenge, the next frontier, might be teaching it to know when that gut feeling is leading it astray. Solving that problem of AI self-awareness, that could be the key to the next great leap in artificial intelligence.